Right, okay. So, solving trig equations. Maybe we should have a quick recap of what we finished off with. We remember we did our special triangle stuff?
No.
Remember we did that? And when you can draw the triangles and you would have, you maybe need to find that somewhere and recap it.
Okay.
Do I really need to recap it?
No.
No, I don't think so. So, on the paper one, there could be, and shut up. I'll start again. Right, so solving trig equations. My method of solving trig equations may be slightly different to other people's. I use graphs to do that because it means that I know that you're going to fully understand the graph method. And I think it's quite nice to have a visual as to what's going on. So, in order to solve these trig equations, you have to remember what these graphs look like. So, sine x. Remember, it starts at 0, 0, makes the s through here, maximum 1, minimum -1. And what are the four numbers that we think about?
90, 180, 360, 270.
And do we remember the radian equivalents? Remember, because we've done radians now.
Sine.
No, so remember,
Like pi 2 pi.
this is pi over 2.
And pi to 2 pi. Pi 2 pi.
This is 3 pi over 2, and this is 2 pi.
Yes.
Okay? So 360 degrees is our 2 pi, and which means that 180 will just be pi, and then 90 would be pi over 2, so it's half pi, and this is 1.5 pi. Okay, so we normally would just say 3 pi over 2. So they're the four markers that you always want to try and remember, yeah?
That's a 2 pi.
That's a 2 pi. I don't know what, it had a little funny glitch when I wrote it. Now, to be honest, most people quite like working in degrees and then converting to radians if their question is in a radian. And you can do that, especially if it's on the calc paper, it's going to be much easier for you. But just be aware that these are the equivalents. Then obviously the cos graph, very similar to the sine graph, but it starts up here at 1 on the y-axis. But the numbers are the same, those main feature numbers are the same. So it's the 90, 180, 270, 360, but obviously those are different points. So the sine graph, remember we choose these points because then it goes, starts at 0, goes up to 1, down to 0, down to -1, 0, and keeps on going, yes? Same thing here, or similar thing here, 1, 0, -1, 0, 1. Okay, so that's how you just do your little sketch. When we're doing these questions, I'm going to expect to see a little sketch, and I mean a sketch. Like, so you're going to get super fast at doing these. They don't have to look pretty. As I say, it's more just a visual aid for you. Now, the tan graphs we have got here, because they do come into play sometimes, but the vast majority of the questions you'll see will be the side up plots. Okay, so we'll focus mostly on them, but the tan graph does come in. Remember so the markers I got here again are 90, 180, 270, 360. What's special about 90 and 270? Do you remember? What'd you say? Asymptote, yeah. So there's an asymptote here, and at -90 as well. Okay? And what is an asymptote? Do you remember what that is? Good, it gets really close to it, but doesn't touch. So if you typed into your calculator tan 90, it would say it as an error, because there is no value for tan 90. Remember, for the tan graphs, there's no maximum value or minimum value. They keep going on and on forever. Okay? Now, what's the other feature I need you to remember? So what's the period of the sine and cos graph? Do you remember what period?
It's from there to there.
So how much is that? What's the period for the sine and cos?
So the sine, 180, 360, 370.
Shout that number at me now.
I know, 360. I think it's 360 also. No,
It's
it's
375, not there. No, it's 360. So the period is how long it takes to do one full cycle.
Yeah.
Okay? So that's one full cycle. It takes 360 degrees. So that's your period. And it's the same thing for the cos graph. 360. It takes 360 degrees before it starts repeating again. This is a good recap. It's been a few weeks since we've looked at this. Now, do we recall that if we had sine 4x, how does that compare to just sine x? Do you remember that?
It's different.
It is different, yes. The period does change, yes.
So it stretches it.
It actually shrinks it
Okay.
because what happens is that you had two options. It's just something you went along. What happens is that this 4 tells us that in our normal 360 period, we've now got 4 cycles. Okay? So where our period used to be 360, our period for this one would actually be 90. So it would take the whole graph would happen within 90 degrees. Yes? Do we kind of remember that?
Yeah.
So what happens is that within this period here, oh no, shut up. That's good. That's enough information now to assimilate. Yes, we all good? Yeah, I keep telling myself.
So wait. So it's just saying that it's 4 of them before it gets to like one.
Yes, so if often it's quite nice to just often base it on the original 360 degrees. So if we do, that means that there would be 4 of those cycles within the 360. Yes.
Alright.
Yes? Done? Okay? Yes? Right, so let's get on to actually solving stuff. So to solve the equation sine x equals 0.5. So this is our equation. Now this is a pretty straightforward one. She says. So we're trying to say which value of x could I have here that when I stick it in my calculator, will I get a value of 0.5? Now, we know from GCSE level what can we do to find one of the values? How am I finding this missing value? If I know that sine of something is 0.5.
Sine inverse.
Inverse sine. Perfect. Yes?
Oh yeah.
So we just do sine to the minus 1 of 0.5. And let's chuck that in our calc. As she does. Count out. Let's just get forward back.
Yes, that's what happened.
Alright, so if our calculation were degrees, we would find that the answer is 30, yes? So we say, we're great, we're done, let's move on. However, they have specified that they want all values between 0 and 360, okay? So we have to say to ourselves, well, what does that mean? There must be more than one solution. So we look at our graph, okay, so here's a picture of our graph between 0 and 360. They are trying to say which values of x give us the answer of 0.5. Okay, so what we do is we find 0.5 on the y-axis. Okay, so because our equation has to equal 0.5, we find 0.5 on the y-axis, and we just draw horizontal line. Okay, so we've got that line there.
Oh.
That line, that horizontal line at 0.5 has hit our sine graph how many times? Twice. So that means that we're going to have to give them 2 answers. One of them is here, and the other is here. Yes? Now, our calculator will always give you the answer closest to the y-axis. So I've done that on purpose because sometimes they will give you a negative value. Okay? So they will give you the answer closest to the y-axis. So this is the one that we've already got. So we know that this portion here, so this amount here represents 30 degrees. You all see that?
Yeah.
Now, do we remember that our sine graph is symmetrical? So this bump here is symmetrical, yes? Which means that if this portion here represents 30, then this portion here must also represent 30, yes? Does that make sense? Which means that our other value would be 150. Yeah? Does that make sense? So, as it says here, the symmetry of the graph shows the second solution is 150. So, if you typed into your calculator sine 150, you would also get the value of 0.5. Yeah? Now, these graphs keep going on and on and on forever. So, we could, if they'd asked for even more, find some extra ones. We know it repeats every 360 degrees. So what would be a fast way of finding? So we know that x is either 30 or 150. But if their range was bigger than that, what could we do with these two numbers to find any more solutions? If we know it repeats every 360. Add them to 360. Okay? That's all you have to do. So if we had wanted any more, we could say that there would be 390 and 510. Yes? Or we could add 360 again, and we could keep going. Yes? Do you all understand that?
Yeah.
So because the graph repeats every 360, we would just keep adding 360 if we wanted to find any additional solutions. I've already agreed. Equally, if my range had been in a negative area, I could have subtracted 360 from both of these. Yes? Okay, because our value of x can be negative. Alright, so don't think it always has to be positive. We got it? Plus? Yeah? Pretty easy. Next one. So this one's a cos. Okay, so there's a lot less written here, so you're going to have to write a lot more. So I did the first one lesson for you. So I've done your sketch for you. Okay, so here's your sketch. It goes between 0 and 360. And our interval happens to be between 0 and 360. So that's helpful. We're finding cos x equals negative 0.5. So what are we going to do this time? You will do. Well, what was the first thing we did last time? Do you remember? We drew the line. Yes? Oh, no, maybe we did. No, we did the count, didn't we? So I'll shut up. Yes, let's do the inverse of this then. So let's find x. So we'll do cos to the minus 1 of negative 0.5.
Yeah.
120. Merci. And then what do we do?
You have to draw that line.
So we draw that line. So it can be dotted or solid, doesn't matter. So that's at negative 0.5. Now on these diagrams, it's nice and easy. I've chosen values that you can easily see where they are. When you're doing your sketches, it really doesn't matter where you draw your horizontal line. As long as it's in the positive section if it's positive and in the negative section if it's negative, you don't have to stress where it is. Okay, so you don't have to worry about scale. So once I've done that, I see where does that horizontal line hit my cos curve. So I hit, well, how many times does it hit it? Twice. And you will find that the vast majority of questions, you'll be given two answers. So it hits it here and here. Okay? Now our calculator told us 120. So which one of those two values is the 120 one? This one here, yeah? You're happy with that?
Yeah.
Now, some people have different ways of doing these ones because they just the way their heads work. Now, I can see that this whole graph has an axis of symmetry around here. Yes? So I know that this amount here represents 120 degrees. So symmetrically, this amount here would also represent 120 degrees. Yes? So I could do 360 subtract 120 to give me 240. Okay? Now, some people might say, okay, I'm going to work out what this baby bit here is. And I see that that baby bit there is 30. And so I'm going to subtract 30 from the 270. Now, you get the same answer no matter how you do it. So it really doesn't matter as long as you are using the correct symmetry. Alright? So, the solving the equation between those ranges are that x is 120 and 240. Again, we know it can repeat, so had they asked us for a different interval, we could have just kept adding 360 to those numbers. Right, next one is a tan. So, we know that tan x equals 2, so what's the first thing we do? Inverse. Yeah? So we're going to say x equals tan to the minus 1, 2.
It's 63.4349.
63.4. Try to the answer there. C. Oh, look, I've just rounded it to 63. That's a mistake. So we know that x is 63.4. So then we've got our diagram. Lovely jubbly. So we've gone from 0 to 360, which we normally would do. The tan is that funny one, remember? So it's a blip. So the best thing is to draw the asymptotes. And then you do a blip up, and then a kink, and then a blip forward. That's very technical. So if I was drawing this myself, obviously you've got the diagram. I would do 90, 180, 270, 360. I would draw an asymptote. I would then draw a blip, draw a kink bit, and then a kink bit. Okay, and that's totally fine. That's how you do your tank graph. Okay?
Okay.
Alright, so 90, 180, 270, 360. Asymptote. Blip, kink, blip. Alright? So we've already got that diagram. Looks exactly the same. And so we draw, and again, as I said, it doesn't matter what your, that was bad. It doesn't matter where your line goes, as long as it's in the positive, it's in the positive section, you get that visual representation. So I could draw any horizontal line, just so you see roughly where it is. So I've got my horizontal line at 2, and I see it hits my graph here and here within my original range. So I know that this value here is 63, yeah? So if that bit there is 63, hopefully you can see that it repeats. Now this period, I want to talk about this, the period of the tan graph is not 360.
180.
It's only 180, yes. So I can write that in the beginning if you like. So the period of the tan graph is 180 because it repeats every 180 periods. Okay, so if I can see that this bit here is 63, then I can see that this bit here must also be 63. So I would do 180 plus 63. Okay, so my two solutions I've got are 63 and 243. Now it's super important that when you do this, you always go back to your original question and say, have I got all of the values I need? And I haven't, because I need to go from negative 180 all the way up to 720. Now, we know that we can just keep adding 180 and subtracting 180, and that's a really fast thing to do. So it doesn't matter if you find an extra one, you can just cross it out, if you understand what I mean. So we do 63, subtract 180, what do we get?
Well, we need, yeah.
A rule?
Minus 100.
So minus 117, is that what you said?
Yeah.
So my final answer is negative 117,
And then that is.
and then 63, and then 243. Because if I took 180 from that, I know I would go past 180. Okay? And so we're going to now have to add 180. So what's 42?
No. Yeah.
Is it?
Let's give a location.
And
Oh, you
then
got 4, 2, 3, 4.
what is from 2, 4, 3? We're adding 180 to this number.
No, 180. Oh, you got. It can't be that.
Yeah, it is.
No. Maybe.
And then
Wait for me.
603. I wrote it down in my head, but what's on this? And then 783. That's gone past, hasn't it? Yeah. Okay, so they are our solutions for that range. Alright, so this one, sine x equals negative 0.7. So our first thing is to do the sine minus 1, yeah? And what value do we get?
Minus 4, 4, 4, 4.
Okay, so we've got negative 44.4 degrees.
Yeah.
Okay? So I think. I'm thinking maybe let's ignore this diagram. Let's have to do this normally. So we're going to have to do a little sketch. So, and it's a little sketch. So you've got your 90, 180, 270, 360. Now notice I'm actually sticking with degrees. Okay? Now the question range is actually radians.
So is it minus 180 to 1?
Yes. But you must make sure that your final answer is given as radians. But I think just the fact that the numbers are so small when it comes to radians, it freaks people out and they don't really like it. So it may be better for you psychologically to keep working with degrees. So for the sine graph, remember it's 0, 1, 0, negative 1, 1. So we draw our sketch. Okay, so that should take you just literally a few seconds. And we're finding where it's negative 0.7. Okay, so I know that that value is down here. Okay, can't stress enough. Doesn't matter if it's not in the right place. I've done it more than a half because I know it's more than a half. So I know it's this value here and this value here for my diagram. Now, I did say that the calculator gives you the answer closest to the y-axis, which is why the value of negative 44.4 is not on my diagram. So, visually, I'm just going to keep it going back here. So this would be here in the middle, negative 90, and this would be negative 180. Okay, so just following my thing. And so my calculator's just given me this value here at negative 44.4. Okay? So it means that this portion here, this bit here, is worth 44.4. Do you see where I dropped my negative? Yes?
0.
Because from 0 to that point is worth 44.4, yes? So what you would do to find this solution is negative 80 plus 44.4. See that? Okay, let's just get you to get that in your heads. So this value is just 44.4, which means that this value would be 44.4. So you're going to do 180 plus 44.4. Yes? So it becomes less negative. And what is that value?
Minus 135.
So that's negative 135.6. And within our range of negative pi to pi, or the negative 180 to 180, they are the only two solutions. Okay? So I know that x is negative 135.6 or negative 44.4, but they are both in degrees. here's the thing. How do we change something from a degree to a radian? Do you remember?
Oh, we gotta do pi over,
So dig to radian, we have to multiply by pi over 180.
yes.
Okay? So that's the rule. So from a degree to a radian, you're just going to multiply it by pi over 180. And so you can literally stick it in your calc. And so you can do negative 135.6 multiplied by pi over 180. So all of the ones we've done so far, well actually the first question may not be, but most of them would have been with a calculator. Okay, so you had access to your calculator. Okay, so there are two values for three figures. Okay, so okay? Yes. Oh, does it? Interesting. Good reading. So this one would be that. Thank you so much. I'll show it because I did not read.
But then the other one too.
That is two decimal places already done. That's Alright, so same thing. I'm going to leave you to do this one and then we can go through